we are going to create U chart using Excel. U chart stand for defect per unit. Whenever you have a defect category type, you can use U chart or C chart. C for count and U for defect per unit. And here what we are going to do it is that we are going to create one complete sample under 10 minutes. You will be amazed that exactly how Minitab offers the solution. Exactly, you can do it in Excel also as well. The only thing is that you have to remember this formula. Using this formula, you can create similar U chart as such. When I say similar chart, you can create the same result as such. For example, let's say now, if you look at here, 7.64 is the lower control limit. And exactly Excel, we got the same thing, right? And Minitab says that 12.35 is the average. So exactly the same. And then similarly 17 percentage we have got their upper control limit, right? So we got the same value also as well, right? Now what we are going to do it is that from the scratch we are going to develop this one, and so that you'll get an idea that how the calculations happening, and mainly how to create this line 3 line horizontal chart, right? And also some of the key important aspect to consider, that also as we go along we can discuss that also as well, right? Let's get going. So this is the dummy template I have, where only when you say defect per unit, so what do you, just to give you bigger picture, defect per unit, what we are saying is that it's a U chart, right? U chart basically is that you have a defect divided by whatever the volume. Volume could be anything, right? Whatever the objects you have in total, that one, right? For example, simple max. Let's say you have one defect or 100. That means defect rate is 1%, and in other word, yield is 99%, right? That's what we can say that. So this is the high level idea. And in the defect, whenever you're talking about bar, BAR bar, another word, for example, U bar we have, C bar we have, and then X RR chart we have, R bar we have, and then P chart we have, P bar we have, and all that. Wherever bar is there, that refers to an average, right? So whenever bar in the entire control chart, all the 7 control chart, so bar refers to an average. So let's get started. So mobile, let's say I'm going to keep it a fixed sample, 1000 sample, I'm going to take it. Out of 1000 sample, number of defect, or you can call it as flaws, or defect, or scrap, or the CTQs, against the CTQ, something is missing and all that, right? For example, mobile cover is missing, or the scratch is there on the screen, or it could be any defect, right? So we are saying that defect, maybe I'll make it as a direct word called defect. So remember that defective is different and defect is different. One defective can have multiple defects. So let's go ahead, and then I'm going to give it random between, let's say the defect range is between 1 to 20 as an example. So now we have got this number. And the first thing what we can do is that we can find out the individual percentage, right? So how to find? Same formula, defect by 1000. For example, in this case, 14. Let me just keep this value as constant, value. Otherwise, dynamically it will be changing. So 1.4, and then dragging it. So the best percentage we have got, the minimum, in other word, the minimum defect we had 0.2, right? And the maximum defect we have at 1.9%. Okay, so this we got that, right? Flaws per unit we got it. And now we need U bar, right? Since the denominator are same, we can go ahead and take this average. For example, let's say even if you say that average like this, since our denominator are same, we can do that. But ideally, so always have a habit of keeping like this: sum of loss or defect, sum of mobile, right? So volume. So this will give you the right percentage, and then you can drag this up. So it's gonna be same, and you can also write it here also as well, like same like this, just doing it parallelly. So number of samples, and then you have number of defects, right? And then per unit, how we are gonna do it? 260 by 250. So 1.04. Exactly both value are matching, right? The beauty about this one is that even if you shift the in a number, for example, suddenly you have taken 500 samples, right? Still you will end up getting the right percentage, right? So that's the reason. Okay. And then n will play a role because we do need n also as well as part of the formula. N we can say here 1000, right? I'll just call this value, and then we can start doing that calculations. How we can calculate is that maybe I don't need this. I can directly do it here itself, right? So what we can do it is that u bar. This is the u bar for us, right? So this u bar uh, plus this is we are talking about upper control, right? Plus 3. Then what I'm doing it, this 3 square root of, maybe I can put it this way, bracket 3 times square root of u bar, again u bar, divided by, and then n. N is this one. So that means UCL is going to be 2 percentage example, right? I mean, I'll keep it 2 digit. So 2.2 percentage. So what value I'm going to dynamically use it? All the value I'm going to use dynamically, right? What I will give, function F4 I will give, just select this value. And similarly, I will select these two values also. Then function F4 I will give. Enter. So now what I can do it, I can just copy paste. So the same value has been pasted. The next step is that copy paste the same thing here. The only thing is instead of plus, we are going to apply minus because as a formula suggests. So that means minimum we are getting it 0.7 percentage, and u bar is 1.1 percentage. Maximum we are getting 2 percentage. How we can do? So you just select all these one, go to insert, and then recommended chart. In the recommended chart, this is suggesting this chart. You can directly take this up. Okay, now I will just give a title called U chart for mobile defects. Okay, now this is done. And now a couple of things they need to do. So I don't need to pay. Okay, first let's find out this value. We got that 1.4 and all that is all rolling one, all are well within the limit, right? So there is no outlier is there, and there are only common cause exists, no special cause exists in this chart, right? This process seems to be controlled, right? So what you can do, this last one, you can click on this and add only label for this, and then right click again, you can do a formatting, you can bring it up, right? For example, right? Similarly, you can just click the last one, and then because otherwise it will look very clumsy. So then I will just keep it on top above, right? So what I will do, I will just make this number bold, slightly up. Maybe I will make it this. So this is again, similarly, I will do it for this also. For U bar, I will make this as okay. So I will keep it on the right side. It is there. I'll keep it on the above. Just keep it this. Okay. And this also I will do that slight formatting. Okay. and then this one to formatting. I'll keep it here. Right. So now the beautiful U chart is using this one has been calculated. Now you can see this is what we have got for this one, right? Furthermore, I wanted to keep that, I wanted to reverse this one because the lesser the defect is good, right? So I will keep it like this color. I will change it now. What I will do, I will just go to format and then shape outline. I will give light green example, and maybe the center line, I will keep it blue color. And then the upper one, we should not have more and more rejection. So that means I will give red example, right? But you can customize to your color palette or color format as well. So this is what it is. So it gives a grade one, whether the process is one. Let's say artificially I'll make this instead of, let's say, instead of 13 error, we have got so much error. For example, let's say we got 130 error. This is really high, right? So you see that this is going up, right? And maybe I'll undo it. Maybe I'll just show you how the outlier looks like, right? For example, instead of 13, I'll just make this number. Let's say we had double that one, right? Double the issues, 26. So again, this is an outlier, right? So we can easily find out whether outlier is there or not there, and all that we can easily find out. Let's see whether the same thing Minitab is giving the same result or not, right? Let's do that. So copy this data because Minitab will calculate all these automatically. So go here, and I'm just going to keep these values here, right? What I'm going to do is that go to stat and then directly go to control chart and then attribute chart and then U chart. Have a click on this. So mobile defect divided by mobile. Okay. Now you see that let's notice that the same value we are getting in or not, right? So that's the question. What I'll do, I will just add that line also as well. Okay, let's compare. So here we are getting that 1.1 percentage. Here also exactly 0.1, 1.09. Let's see that 1.09, exactly the same thing. And then 2.08, 2.08, exactly the same. And then, for example, any value, if you take it, like 2.6 is outlier, right? So here also 2.6, let's see what Minitab gives. 2.6 percentage, right? 2.6 percentage an outlier. Exactly, it gives everything. And then let's say I'm changing it back to this one. Let's say I'm skipping it here. Now it doesn't show any outlier. Let's see what Minitab is giving the result. So what I'm going to do, I'm going to make it this 26 to 13 and come back to graph and then right click on this, update the graph automatically. Now the scale slightly has got changed, 0.7 and 1 percentage and 2 percentage, exactly the same thing. And here it shows that there's no outlay. Here also it shows no outlay, right? So far it is great. I mean, the tricky part comes into play is that when you change your denominator, right, the control limits also get changed, right? How Minitab does is that Minitab calculates accurately using the subgroup size, but in the Excel it is difficult to do. For example, let's say you're taking the samples, let's say this sample, suddenly you went for 500 sample example, and then like this it is the example, right? So the same thing I will just copy paste. Now we've got some values, right? For example, let's say I think I mean, U bar will get the same, but let's see whether we are getting the same value for other values. So what I'm doing it, I'm just pasting this value here and going back to this one and see. So now this has been updated 2.38, but this also same. But actually, if you have in this case, how many tab works is that. So in this among these two number, 500 and 1000 is a bigger value. So the real test happens when you have a so much variations. For example, let's say I'm just giving it. My sample is between 500 to 1000. Now it will not be as accurate as Minitab. Minitab will give you most accurate value. For example, let's say now it's giving 2.88, right? So first thing what I will do, I will convert back to values as it dynamically will change otherwise. So I'm just copying this one and going back to this, pasting it here and going back to the chart, and then you see the 2.6, but here 2.88. Why? Because here we are talking about it, we have taken that first value, right? Even if you take example, even if you take maximum value, okay, even if you take maximum value, so you're going to get 2.51, but actually 2.65. Although there is a very subtle difference, but there are two outlier it is showing up and all that. But only thing is that still it is not right, right? So maximum concept also we might not work out sometime. When you have, remember, when you have very only one kind of thing, for example, let's say just keeping it again, going back to the original example, 1000, and then you keep shifting it like 500 and all that, right? So I think it probably might get the same value, right? So for example, you're getting it 2.54, right? And I'm going back to this Excel, copy this data, go back and paste it here as well, and go back to chart and see the result, 2.69, 2 point now. The value is wrong. That's what it is a bit tricky. So keeping it all the way down. Okay, I'm pasting it all. I realized that I have not pasted well. I'm just keep flipping between 1000 and this one. Let's say whether Minitab and Excel are same, right? So just pasting here, going back to this one, 2.47. 2.47, I think it is same. Why? Because it doesn't have the too much sample variation. If you have too much sample variation, then you have to do it carefully in Excel, because Excel might tend to give a wrong value. So that is one point you need to know. Another aspect is that sometimes you might get zero, for example, minus value also as well in the LCL, right? For example, let's say you're getting that LCL, theoretically you're getting that 1%, right? As the LCL, but technically we don't say 0% error, right? So that we need to assume as, I mean, -1% we need to assume as 0%, right? So that is also one other important point I wanted to share. I hope you find this Excel versus Minitab comparison with the real-time demonstration easy. Please start using the control chart, and it makes lots of difference. Thank you so much. Take care.